Okay, I think we can start now. I welcome everybody to this webinar about tree layouts. My name is Benjamin Niedermann. I'm a software developer at yWorks and a member of the layout algorithms team. This basically means that I daily work on layout algorithms, improving them, integrating new features, but I also develop new layout techniques that you can use to visualize your connected data. In this series of webinars, I would like to introduce to different types of layouts that are offered by the yFiles library. All these layouts have in common that you can use them to visualize your network data, your graph data completely automatically, but you can also create interactive visualizations with these layout techniques. And today I would like to introduce a very special and basic layout, namely the tree layout, which is a part of the yFiles library. In contrast to the other layout techniques, this layout assumes that the graphs and network data are tree structures. So what this means, I will explain in the webinar later on. But assuming this, it can exploit these properties of this graph structure in order to improve the layouts. And today's webinar will be structured as follows. First of all, I will present some use cases, giving you some motivation when to use the tree layout and what kind of applications for which you can use them. Then after that, I will present the basic principles about trees and tree layouts. And then after that, I will give you a concrete coding example in yFiles HTML, showing you how to apply the tree layout on some sample data. And then finally, in the conclusion part, I will do a very short wrap up. And in case that you have some questions, then please just put them in the chat and I will try to answer them after the webinar. In case that you watch this video on YouTube afterwards, you can also place your questions below the YouTube video, and then we will try to answer these questions as soon as possible. So let's start with the use cases. And I would like to start with a very simple example of a company that whose structure we would like to visualize. And this company consists of different departments. So for example, the sales department, marketing department, and so on. And of course, these departments have some teams and employees, and this is again split into further sub-departments or sub-teams. And the tree layout helps us to visualize this kind of data. So this is a very typical example where we just want to visualize hierarchic data using the basic information of this data. And this gives us a rough idea of how the company looks like. So with one glance, at one glance, we can basically understand the structure of the company. Sometimes it is also interesting to get even more details to also visualize the team members and the employees. And in that case, we can, of course, replace these nodes by nodes representing each one employee. So this is one example that you will also later see in the coding example, where each member of the company becomes an own node, and the CEO is at the top of the layout, and then we have a classic tree layout. And if you are interested in seeing how this works, and you can just go to the yWorks demos page and have a look at the interactive org chart demo. I will also put this later on below the YouTube video as a link so that you can easily access it. But as I already said, I will use this example later on also in the coding example. So there I will also present the demo a bit. Another example comes from business planning. Here, the idea is that we would like to analyze the costs of a product. And the product is basically the topmost node, in that case, the leftmost node. And then we can split this product costs in other costs. So for example, based on the features, the product consists of, and then the costs which we need to develop it. And then we can basically base our decisions on this tree visualization, which also allows us to visualize different cases. So for example, here we have a rapid development for the feature, and then we can assess the costs with some probabilities for different market reactions and so on. And this gives us, again, some hierarchic information that we can easily visualize with the tree layout of yFiles. Another example that I would like to mention are decision support systems. Here, the idea is that the top node is an initial question that we would like to solve. So for example, if you assume that you consider a television company, and this television company has a support hotline where you can call if you have some problem with your television, then the support hotline can use this tree layout to structure the conversation. So the idea would be then that the customer is asked whether the television is plugged in, and if this is the case, then you can go to the next node and see how to continue. If it is not plugged in, then you could just say, okay, please plug in the television. And of course, you can also do this interactively. And this is what I would like to show you in a short demo. Here you have the very same graph, and in an interactive scenario, you could also do it a bit differently, namely that you just consider the current path that you're going along. So again, using this example of a support hotline for televisions, the first question would be, is the television plugged in? And if the user says, or the colleague says yes, then you can click here, and then you can ask the next question, do you see the red light? And so on. And this gives you basically the possibility to partly build the tree layout. And later on, I also will sketch how to do this with a yFiles HTML library. The next example does not come from business, but it's completely different. What you can see here is a handmade drawing of basically of a graph that should help you to decide which role to take in the game Dungeons and Dragons. So the starting point is here, and the idea is that you do basically the same thing as in the example before. You answer some questions, and then you try to find your role. So for example, the wizard. And some of my colleagues are really fans of Dungeons and Dragons, so they decided to take this diagram and use it in yFiles, and then use the yFiles HTML tree layout to automatically create a drawing of this. And the result is then this drawing. And as you see, here is the start node at the very top of the drawing, which is very typically, and then you have here this typical tree layout. If you have a look at this a bit more in detail, you will find some cycles. And if you know already the tree layout, you may know that the tree layout does not support cycles. As I will also explain later on, you can circumvent this problem by first removing these edges and then adding the edges after layouting and integrating them. And in the coding example, I also will show how to do this. If you are interested in this demo, you can just have a look at our homepage and then DND, and there you can find the following demo. One moment, please. And again, you can interactively use this demo to find your role in Dungeons and Dragons. So for example, you can use this interactive view here, and you can click on these buttons until you have found your role. And If you would like to use this example or just to try it out, or you would like to use it in Wired Live, you can also download it and then and then you can use it there. Yeah, apart from that, one moment. Yep. So these examples basically give you an idea when to use the tree layout. And these examples should already give you a short overview for the answer when to use the tree layout, namely always if you have tree-like structure. So for decision making, this is a typical use case of organization charts or for hierarchies. And I wrote here tree-like structures, as I already said. There are possibilities to use the tree layout on graphs that are not trees. But this I will later on show in the coding example how to do this. In the next part, I would like to introduce you to some principles about trees and tree layouts. And I would like to start with the trees. So what is a tree? So I used this term very often already, and now I should explain what I actually mean with a tree. A tree is a special type of graph which is connected and has no cycles. Connected means that it has only one component, and so basically it means that for any for any pair of nodes, there is a path that connects these nodes. This means that the graph is connected. Actually, you can also use multiple trees in the tree layout, then it just separately will lay out these trees. So what does it mean that a graph has no cycles? So for example, we are not allowed to introduce this edge here. Because then we create a cycle in this graph, and then this is not a tree anymore. So put differently, the path from this node to this node is not uniquely defined anymore, but there are two paths. I can go from here along this path, or I just can go here. And this means that there's a cycle. In the remainder of this webinar, I would also like to use the following two terms, namely leaf nodes and internal nodes. A leaf node is a node that has only one edge. So all the red nodes are leaf nodes. So in this drawing, the outermost nodes. In other drawings, they can be placed differently, but the important property is that these nodes have only one edge incident. And all other nodes are called internal nodes. And another thing that I would like to define is the rooted tree. So if you consider hierarchic data, for example, that is based on a tree, there's typically one node at the top that is most important. And then this node is split into further child nodes, which are less important, and so on. And this gives you the hierarchy. And this topmost node in this hierarchy, we call the root node. And this root node is predefined. So you basically need to define which of the nodes of a tree is the root node. But when you have defined this basically gives you a parent-child relation. So for example, for this node, the children are these two nodes here. And for this node, the children are these nodes here. And this parent-child relation is very important for drawing the graph, because it gives us some kind of structure how we can actually draw that graph. So now what we can do is we can measure the distance between the nodes and the root node. And this basically gives us then the possibility to assign the nodes to layers. So we can say that this node, for example, the root node is in layer 0. These two nodes, which are the children of the root node, are in layer 1. The children of the root node are in layer 2, and so on. And the leaf nodes are in the last layer. And in this special case, or in this special example, the leaf nodes are all in layer 5. And this gives us the possibility to structure the tree. So far, I have just talked about trees, so a special type of graph. And all terms that I've introduced are completely independent from the drawing. So I can define a root node, and based on this root node, I can define layers and also the leaf nodes and so on. But now I would like to talk about how to draw a tree. And a tree layout, and especially the tree layout in yFiles, is a specialized method for drawing a tree. And of course, there are many different ways to draw a tree, and I would like to give you a short sketch how the tree layout actually does this, which then helps you to customize the tree layout. So the basic idea of the tree layout mechanism is that we do a bottom to top drawing, which basically means that we start with the leaf nodes and we just draw the leaf nodes. This is of course trivial because the leaf nodes are just the nodes themselves. So we just place them here and then we continue. In the next step, we consider the nodes of the next layer. And this time we combine, for example, this orange node with its two child nodes. And this gives us a new drawing. And we do this for all of the subtrees. So each of these subtrees are drawn basically recursively by first drawing the leaf nodes and then the parent nodes and the leaf nodes. And we continue with this process layer by layer. So for example, in this case, we again take the drawings that we already have and combine them with a common parent node. And we continue this process until we have reached the root node. And this gives us the drawing. And of course, it depends very much on how we draw these subtrees, how the tree looks like at the end. And this is also the reason why I explain you this in detail. There is the possibility for tree layouts to define the subtrees, how they are basically styled or which kind of layout they get. So the idea is that you can define for each subtree an own layout style. And this is called a node placer. So basically the idea is that you can define for each subtree a node placer, and this node placer is then responsible for placing the parent node and then the two subtree nodes, subtrees of this node that are anchored at this node. And this is what you can customize with the tree layout. And later on in the coding example, I will show you this in greater detail. So the question is, of course, first of all, what kind of layouts do we support with a tree layout? And there are different types. So there's some, of course, some default layout, which is called the default node placer. So if you have a look at the source code, you just need to take this word here and add node placer to this, and then you get the corresponding class for the node placer. So in this case, the default node placer just places the children nodes of a parent closely to this parent and the children nodes besides each other. So this basically gives you already some kind of layering or some kind of horizontal alignment of the nodes. Here, the layer node placer, here the idea is that all nodes that have the same distance to the root node are aligned on the same horizontal line. So for example, here these nodes all have distance 2 to the root nodes if we count the edges. So there's one edge and 2 edges to the root node. And this is the reason why we placed them here on the horizontal line. Maybe one remark, these nodes here are not necessarily nodes, or these blue rectangles are not necessarily nodes, but they can also be subtrees. So in this case, for the left-right node placer, you can also consider these blue rectangles as entire subtrees that are already drawn with some other node placers. And here the idea is that if you look at the parent node, all the subtrees are drawn along the main axis, namely either on the left-hand side or on the right-hand side, and only the last one is placed at the bottom if we want to. We can also configure it that all nodes are placed on the left and right-hand side. And continuing with the node placers shortly, the double line here, the idea is that the subtrees are placed in 2 lines so that they are alternating, which makes the drawing a bit more compact. Then there's also a compact node placer, which is really optimized for this case that we want to save space and want to have a very compact drawing. And then there's also the assistant node placer, which is very similar to the left and right node placer, but here the idea is that we can define 2 types of nodes. And the dark blue nodes are placed along this main axis, and the lightened, the other blue nodes are placed on a horizontal line. And finally, there's also a grid node placer that just places the subtrees of the root node on a grid. And there are further node placers, and if you're interested in which other types of node placers there are, then I recommend you to have a look at the yFiles documentation or at the guide of yFiles. And this already brings me to the coding example, and I would like to start or show you an example where we have a look at the at the structure of a company. And what we would like to visualize is the members of the company and the roles in this hierarchy. And the starting point is a very simple JSON file. And this JSON file is structured as follows. We have here some block basically showing or specifying one node. And this is the CEO of the company, which is at the top of the file. And then there are the subordinates, which are basically then the child nodes in the tree. So this is basically the next hierarchy. And here we also list all nodes, and each node can, of course, have, again, further team members and so on. And this gives you a hierarchy. So for this concrete screenshot that you can see here, we have here Erica Joplin, and then direct successor of Erica Joplin is then Amy Kane, and so on. And this gives you already a hierarchy. And now I would like to skip to the source code to show you how to basically set up this tree layout. So the idea is that we have a demo that we can execute here. I just restart this. And the idea is every time the graph needs to be layouted newly, we call this create layout method here. And this create layout method gets a graph as a parameter, and then we need to create a layout, which is the tree layout, also a layout data, and then we return both, and then we can, and then this creates the tree layout. The graph we later on use to configure the layout data and the layout. And this is the result of just this method. So we just created a simple tree layout without configuring it, and also the layout data. And on the first, or at the first glance, what we can note is that it's very long. And this is just because we use the default node placer, and this default node placer places all child nodes of a parent node besides each other. So if we have a look at this node here, all these nodes are placed, or the child nodes are placed besides each other, and this expands basically the entire tree layout. So later on, I will show you how to use another node placer, which makes this much more compact. And Another thing that I would like to observe at this point is that the segments, the vertical segments, are very short, and I also will later on show you how to change this. But this already gives you a very basic tree layout where you already can recognize the 3 different themes that are marked orange, blue, and red. So in the next step, so this is basically the result of the basic setup. And then in the next step, I will explain how to actually improve this placement of the nodes here so that they are not placed along this very long horizontal line here, but such that the drawing becomes more compact. And I also will explain how we can a bit improve on the positions of the nodes such that the vertical segments become longer. And this is the part of the node places. So first of all, I would like to show you how to use node places in general. And then becomes more complex and more complex with introducing new node places. But first, I would like to start with a very simple example of a node placer. And what I can do is I can define a default node placer. And here we can just use one of these node placers that I've shown you before. So for example, there's the compact node placer, which would be of course the first idea to use if you have a layout that should be compact. And if I execute this now, the result is much more compact, but maybe not what we want to. So I would like to have a layout where the top level layers are placed as in the default layout, so besides each other, but the nodes of the lower layers should be really compact. So they should not be placed besides each other, but they should be stacked somehow. And later on, I will explain you how to do this. But first of all, I would like to show you some choices of node places, just that you can see some examples. So another example would be that the double line node placer, for example. No, I'm sorry. Yeah. Mm. Yeah, okay. Now the double line node placer is used, and what you can see is that here, for example, these 3 subtrees are placed in 2 double lines. So this subtree and this subtree and this subtree or this subtree and this subtree are placed on one line, and then this is placed on another line. And this is again done for the other nodes. So for example, for the lower levels of or lower layers of the tree, this would be a nice layout, but for the upper layer, this does not work very well. So here again, we need to somehow decide for the layers which we would like to use. So for this example, I just use the default node layer as a basic node layer, and I also configure it a bit so that the vertical segments become a bit more longer. And for this, we can here define the minimum first segment length, and I set it maybe to 50 pixels. And the minimum last segment length, I set to 50 pixels also. And if I run this, we can see that the first segment has now a length of 50 pixels and the last also. And this already expresses the tree structure a bit better. The next thing is that I want to define or customize the default node layer for the different layers. And for that, I need to compute the layers of the tree. But this is not very difficult in yFiles because we can use the BFS or the graph search to find the layers. And for that, we just call the BEFS. So this is a graph search, and we need to tell the graph search that it should start at the root, so at the node Erica Joplin. And this is what we can do with this call here. Sorry, this is not right. This call. So the idea is that we define the starting nodes where the graph search starts with the core nodes, and we only consider the node that has the tag or the name Erica Joplin. And then we also need to run this algorithm, namely on the graph. So, and now we have an object layers that stores the layers of the graph. So basically what this object does, it assigns to each object, to each node on which layer it lies. So for Erica Joplin, it assigns 0 for this node 1, for this node 2, for this node 3, and for all of them here below 4, and so on. The next thing is that we use the layers to customize the node places. And to that end, we can define for each node an own node placer. And to that end, we just use the delegate. So the idea is that this delegate goes through the entire graph and asks for each node, which node placer should I use? And as a default value, we just return null, and returning null means that we use the default node placer that we have defined above. So now we can use the layers object to actually do something. So for example, we can ask if whether the current node is on layer 0, so whether it's the root node. So we ask, what is the layer ID of this node? And if this is 0, we know that's the root node. And what we then can do is we can customize the default node placer by returning an on object. And for example, what we can do here is we can just return another value. So this is a very basic example on how to customize this. And what you can see here now is that we use an own default node placer for this layer, introducing long vertical segments. And for the others, these segments are not that long. So and this is a pattern that you can use to basically customize any of your layers. So of course you could also say, okay, for the next layer, I just want to have a distance of 100 and so on. And this basically gives you a very simple and pattern how to use this. And of course, this is not a very realistic example here at this point, but it should show you how to customize the default node placers or the node placers for certain layers. So for this layer, for layer 1, I require a distance of 100 pixels, for example. Yeah, but as I already said, I would like to make the layout more compact. So what I would like to do is to use an entire different node placer for the nodes that are basically the leaf nodes. And to that end, I need to identify the nodes that have only leaf nodes. And for these nodes, I define a left and right node placer. So the first thing that I do is that I take the outgoing edges of the node. And What I then check is whether all the outgoing edges end in the leaf node. And if this is the case, then we have found a subtree that I would like to lay out with a left and right node placer. So what I do is that I take the edges and I map them to their target nodes. And then I use this map to check whether every child node is a leaf node. And for this, I have written a very simple helper function that checks whether each node has only degree 0 at this point, or only one incoming edge, basically, and no outgoing edge. So I check for this child whether it's a leaf. And if this is the case, I want to return a certain node placer. So for example, the left-right node placer. Here I missed a new. And with this, I already get another drawing. So what happens now is that the drawing becomes much more compact. The reason is that we have identified this node. So for example, and we told this node it should use the left-right node placer, which basically means that all the children of this nodes, all the subtrees basically, but in this case all leaf nodes, are placed on the left and right-hand side or at the bottom of this vertical axis. So if we don't want to have this bottom placement, we also can specify this via the options. There is the option place last on bottom, which is the Boolean, and we just say, okay, this should get the false value. And if we execute this again, now there's no node placed at the bottom of the drawing. We further can configure this left-right node placer. So for example, if you look at these nodes, there are some icons telling you whether these people are currently available or whether they are on a journey or whether they are just not available and so on. And what I would like to do is that all nodes or all people that are available are placed on the left-hand side and all others are placed on the right-hand side. And this is quite easy with the left and right placer, because you can specify which should be placed left or right. And to that end, we can use again the layout data at this point. So we are already outside of this definition here. And we use the left right node placers left nodes option. So here we define which nodes are the left nodes. And again, we can use a delegate. So basically we go through the entire graph, and for each node, we ask whether it's a left node or a right node. And to that end, I can use the text status and check whether this is present. So, and this data is just stored in the JSON file. And now what happens is that all children nodes that are available are placed on the left-hand side and all other nodes are placed on the right-hand side. And summarizing, we get a compact layout. So from this very uncompact layout, which is very has a long width or large width and a small height, we came to a solution where we have a compact layout. So basically, the aspect ratio becomes much better for this tree layout. And the reason was that we identified the problem, namely the many leaf nodes that we have at the bottom layer, and we decided to place them along a vertical axis, and this made the layout a bit more compact. Sometimes it would be, it is also desirable to order the subtrees. Sometimes you would like to say, okay, this subtree should be placed on the left-hand side and this subtrees should be placed to the right. In this use case, I just want to place larger subtrees on the left-hand side and smaller subtrees on the right-hand side, so that you can see directly which of the teams are the larger ones and which are the smaller ones. And to that end, you can basically say or tell the layout the order of the outgoing edges. So you can say, okay, for example, this edge here should be to the left of this edge, and so on. And this is what I will do in the next example. So now I would like to define an edge comparator, and the idea is that we consider the outgoing edges of a node and we order them, and this order tells the layout algorithms in which order the subtrees are drawn. So to that end, we use the out edge comparator, and again, we use a delegate here. The idea is that for each edge of the graph, we say which comparator should be used. And not for each edge, but for each node. So for each node, we tell the layout algorithm which comparator it should use for its outgoing edges. And then for each node, we define a comparator, and this is again a lambda function that is based on edges. So we need to compare an edge E1, which is an I edge, and an edge E2, which is also an I edge. And then we need to compare this. And here I need to use the arrow function. So compare, and now I can compare the sizes of these edges, or basically of the target nodes. And I again have some kind of helper function that gives me the team size of this node. So basically what it does, it is just counts the nodes, for example, for this node. So, and when I execute this now, what the result is that the smallest trees are on the left-hand side and the largest tree is on the right-hand side. And if I want to change this order so that the on the large trees are on the subtrees are on the left-hand side and the small ones are on the right-hand side, I just can place here a minus, changing the comparator, and then I get this result. And this was already how to define comparators for the nodes. And of course, I've done this now for all nodes, but you can also do this more specifically for certain nodes or for certain subtrees or substructures that you would like to order. But this should give you some idea how to do this in general. The next thing that I would like to consider is the interaction. So the demo actually allows you to interact with a graph, which I show you now. So what I can do is I can, for example, click here on the plus, and then the nodes are collapsed. This can be very useful if you have a very large graph and you would like to explore this graph step by step, and you don't want to see all of the nodes at the same time. So for example, also in the use case of the decision diagrams, a similar approach is used. And the idea is basically that we use a filtered graph wrapper. And the idea is that this graph only shows or only consists of the nodes that are actually not hidden. So the idea is that we can put in here some the entire graph, and this graph only gives you a view on the nodes that are actually not collapsed, so that are not in the hidden set of nodes. And now every time this create layout method is called, we also get this active node. Maybe you have noticed this when I explained you this method before. So this active node is basically when I click here on this node, this method is called, and I get the graph and also this particular node that is collapsed. And what you may already have recognized, the interaction is not very nice at the moment. So if I click, for example, on this node here, the entire graph here moves, and the node on which I have clicked moves also, which is very strange if you want to interactively explore this graph. But what you would like to have is that the node stays at this point and is fixed at this point, and the remaining graph is changed, but not the node that you have clicked on. So not the position of this node is changed. So here, for example, this node should not move, but it should stay here, and the remaining graph should change. And actually, we can easily do this, and this is not a feature of the tree layout, but it's a stage that you can wrap around the tree layout, and this ensures that the nodes that you have specified to be fixed stay at their points. So what I do is that I ask whether this node exists. So if I do the layout without clicking on any node, the active node is not defined. And if it is not defined, I just do what I've done before. And in case that it is defined, I basically also return the tree layout, but this time I wrap around a stage that fixes certain nodes. And this is the fixed node layout stage. And I wrap this around our basic layout. And what I also need to do is to define which of the nodes I would like to fix. And this is the active node. And to that end, I need to define the fixed node layout stage data. And as an option, it has the, I can specify the fixed nodes. This should not the stage. Fixed node layout data, it's called not stage data. So, and as an option, it has fixed nodes, and here I can just specify the active node. And now when I do the same interaction again, so for example, I click here on David Carey. That's because I haven't used the fixed node layout stage data yet. I need to combine it with the other data. So like this. So now when I click on David Carey, what happens is that this node stays at this position and the remaining graph moves. And this is much more intuitive for the interaction in this case. And now I can play around with this graph. And so, for example, I can just show the heads of the teams, showing a very simple structure, but I also can now expand these nodes again. And of course, I can even more elaborate on this interaction, but this gives you maybe an first idea how to do such interactions and also how to create such decision trees as I've shown before. And finally, I would like to show you what happens if we add edges to the tree that are not tree edges anymore. So that basically create cycles in the tree. And as I already said, the tree layout does not support this. So the idea is that in this example, I just add these edges. These could be cooperations between the people working there or some kind of other information that is that relates these nodes to each other apart from the tree structure. And in this example that I use, I just change here this flag. And this basically means that the graph is annotated with further edges that are non-tree edges. And when I execute this, and now what happens is that I get an exception. So this is an error report because this is in the demo environment. I get an error report and it says the graph is not a tree. And that's because we have introduced edges that create cycles. But this is not a problem. We can actually reduce the graph to a tree and then lay out the graph. And after that, we can add the removed edges again to the layout and get a tree layout with edges that are non-tree edges. So for that, I use the tree reduction stage. And I also need tree reduction data. And now I need to configure them. And I need to tell the layout algorithms which of the edges are non-tree edges. And again, this method, so this delegate, goes through all edges, and for each edge, it asks whether it's a non-tree edge or whether it's a tree edge. And for this, I have a special tag in the data. This is called a relation type. And this should have cooperation. And of course, this data can be defined differently, or you can mark these edges differently, but this is a very simple example for this. And the next thing that I need to do is also to add this tree reduction to our layout and also to add the tree reduction data. The tree reduction can be added to the layout by prepending the stage. So I would like to first reduce the graph to a tree, and then afterwards I want to do the layouts. Therefore, I prepend the stage. Like this. And then I also need to combine the layout data. I only do this for this webinar for the case that we don't consider interactions, but you also need to do this for this part, but I refrain from this at this point. So I add here the tree reduction data, and now I can execute this. And what you can see is that the edges are not drawn. What happens is basically that the tree is drawn without the red edges, and then afterwards the red edges are added. And currently I use straight line edges, which actually does not look very nice, but I can change this later on. But first of all, I want to note that you don't need to do this actually to define the non-tree edges. If you don't do this, the algorithm tries to identify the non-tree edges on its own. So there's some heuristic that then tries to find a good set of non-tree edges and a good set of tree edges, and this is then done automatically. But often you actually know which edges are the non-tree edges, and then you should specify them so that the tree layout algorithms actually knows this. As I said, I also can configure this this edge router, and for this I have already some helper function. So this expects the tree reduction and the tree reduction data. And if I execute this, we get these very nice curvy edges. So I choose these curvy edges so that there's a real contrast between the tree edges and the non-tree edges. If you have a look at this method shortly, what I basically do is that I create an edge router, a non-tree edge router, and I add this non-tree edge router to the tree reduction stage. And at this point, and I also configure this non-tree edge router. So I say, okay, only the affected edges, so only the non-tree edges should be layouted. And I use the curved style. And then I also need to tell, okay, this is a line that does not need to be there. This is duplicated. This is already here. But then I just tell the tree reduction to use this non-tree edge router, and then it uses this to draw these curvy lines. And this already shows how to integrate non-tree edges into a tree layout. And yeah, with this example, I would like to end the coding example and go to the conclusion part. So about the conclusion, what have you learned in this webinar? You have seen the tree layout, and I presented when to use it and also how to use it using a coding example. So the tree layout is especially good for layouts or for visualizations where you would like to visualize decision possibilities or hierarchies. And what you also have seen is that the tree layout of yFiles is highly customizable, because you can change and define the sub layouts. You can define or node places, or define which node places are used for custom subtrees. And then you've also learned how to draw graphs with cycles using a tree reduction and the tree layout. Yeah, and with this, I would like to go to the question round, where you now can ask questions. So I will try to answer them, and I will have a short look at the chat, whether there are some questions. I am. There's the question, the shown layouts all go from top to bottom. Is it also possible to have layouts from left to right? So at the short answer is yes, it is possible. So for example, at the beginning of the webinar, or in the part of the use cases, you have seen that the example with the business planning, this was a layout that that is layouted from left to right. So the root node was on the left-hand side, and the leaf nodes were on the right-hand side. And this can be easily done using a property which is called layout orientation, and is defined directly on the tree layout. And setting it to left to right, for example, you can change the layout direction of this layout. This is a property that is basically defined for most of the layout algorithms of yFiles. The next question is there a possibility of integrating own layouts for subtrees? Okay. So I think that the question is whether the layouts, yeah. So you have the possibility to use node places to define the sub layout, to define the layouts of subtrees. But what you can also do is that you can extend one of these node places and actually place the nodes on your own, which is really advanced. But if you have an idea on how to place some nodes for some certain subtrees on your own, you can do this by extending a node placer and then using this. So basically what you then need to do is to describe the outline of the subtree, and after placing the nodes. And I think there's one final question about the hierarchic layout and tree layouts. The hierarchic layouts also creates drawings in which the node lie in layers. So can I use them instead of the tree layout? So yeah, that's an important observation. So in a previous webinar, I presented a hierarchic layout, and the hierarchic layout also can be used to lay out arbitrary graphs such that the nodes are placed on layers. And the tree layout basically does the same. And using, for example, the layer node placer, you actually can enforce that the nodes are placed on these layers. So in that case, both layouts are quite similar with a difference that the tree layout, of course, does not support non-tree edges by default. But it is really optimized for this case that your data is a tree, and in that case it often makes sense to use the tree layout. Or if you have some layout where you only want to layer some of the nodes and the others, you would like to use other sub layouts. Yeah, I think that is everything about the questions. And with this, I would like to end this webinar. I would like to remark that there is a webinar about Graffiti, I think next week. And if you would like to join this, then just have a look at the web page, and there you can register for this webinar. And apart from this, there will be also, of course, further webinars on layouts. And with this, I would like to wrap up the webinar, and I wish you a happy diagramming.